Before we start, there are some simple rules that will help you deal with any polarization question. So it's worth remembering these three key ideas. And the first thing is that you have to just take them one by one. Go in the direction the light is going and take each polarizer at a time. For each one, you work out the intensity and the direction of polarization, and then you move on to the next. So for each one, to find the intensity, if the incident light is unpolarized, it's the 1/2 rule. If the incident light is polarized, then you use Malice's law. And then to find the direction, the light transmitted by a polarizing sheet is always polarized parallel to the polarizing direction of that sheet. So in this case, the light will be vertically polarized after the first one, then the polarization will be rotated by 60 degrees for the second, and finally it'd be rotated again to be horizontal if any gets through the third. Now we're going to start by drawing what's happening. So we've got an incident light with intensity I0. Then it's going to go through a vertical polarizer. The intensity we'll now call I1, and it will be vertically polarized. Then we go through a second polarizer that is at an angle of 60 degrees. So now it's dropped to an intensity we'll call I2, and the angle, the direction of polarization is now 60 degrees to the vertical. And then finally, we have a horizontal polarizer. So we have I3 coming out, and now the direction of polarization is horizontal. So the rules that we have are that we take one polarizer at a time. The next one is that if it's unpolarized light, we use the 1/2 rule. But if it's polarized light, we use Malice's law. So let's start with the first polarizer. So unpolarized here, which we can draw like that. So 1/2. And that gives us I1 is I0 over 2. Now we get to the second polarizer. So it is polarized incident light, and that means we use Malice's law, or the cos squared law. So that means I2 equals I1 cos squared theta. Theta is 60. Cos 60 is 0.5. So cos squared 60 is 0.25. 0.25. So that means that I2 is 0.25 I1, which is 0.125 I0 because I1 was half of I0. Now the light at this point is polarized parallel to the polarizer. That is something that is always true. So if it's polarized at 60 degrees to the vertical, that means it must be polarized at 30 degrees to the horizontal, which we now need to know because the final polarizer is horizontal. So the third polarizer, Malice's law again, because it's polarized incident light. So that means I3 equals I2 cos squared theta dash. I'll call it theta dash because it's a different angle. Theta dash equals 30 degrees. So I3 is I2 times cos squared 30, which means 0.75i2. And that means 0.75 times 0.125i0, which means 0.09375 I0. So the fraction that gets out, which is I3 over I0, is 0.094. That means about 9.4% comes out the far side of the third polarizer, and it is now horizontally polarized. Now, just to look at what would happen if we took out that middle polarizer. If this, maybe I'll show it in a different color, if all of this was gone, then we would simply have vertically polarized light encountering a horizontal polarizer. Theta would be 90 degrees, so nothing would get through. So the fact that the middle polarizer has been put in here means that in fact some light has come out the final polarizer. So it seems odd to think that putting a component in there increases the amount of light that comes out, but that is what happens, because every time you have a polarizer, the light that comes out, which is decided by the 1/2 rule or Malice's law, is polarized parallel to that polarizer.